In this topic, we're going to study about barbiturates. These are basically derivatives of barbituric acid. So all the drugs which are derived from barbituric acid are called barbiturates. As a short, we also refer to them as Barbs or Barbies, in order to remember them as a mnemonic. So barbiturates and benzodiazepines are very closely related as CNS depressants, but nowadays are in the modern era, these are not as much preferred as benzodiazepines. So the question arises, why? This is because of the physical dependency, or the tolerance and weakness the barbs induce in the person who is taking them, and it has also very severe withdrawal systems. So the benzos are often more preferred as compared to barbiturates. And how do they affect on the human body? So just like benzos, they act on the GABA receptors, but on different GABA receptor sites of wait a minute, of GABA receptors. Okay. So what they do actually is they increase the duration of opening of chloride ion channels. So we can observe here that the chloride ions are coming in, and for a longer period of time, as compared to without the drug, without the barbiturates in their body. And these cause hyperpolarization in the inner cell membrane, inner part of the cytoplasm, and which allows the sedation and hypnotic effect in our body. And the other thing they do is that they block the high frequency sodium channels. Now, since the sodium normally the sodium ion channels are entering into the cell membrane, so in order to regulate the action potential of the body in the cells. So when the patient takes barbiturates, what happens is these block the entry of the and sodium ion channels into the cell membrane. And the other thing they do is they block the glutamate receptors. These are also very important in the playing a part in the hyperpolarizations and sedation effects. And these actually glutamate receptors also help to these are kind of excitatory receptors. Okay, moving on. Now we will study about the classification and actions of the barbiturates. These barbs are classed in the main. Basically, well, there are many barbs, of course, but we'll talk about the main one. Basically, thiopental. Thiopental. It's very important name nowadays as an anesthetic. Okay, anesthetic. It has very rapid onset of action and only 30-minute duration of action. So we can rapid, for example, if a person is suffering from seizures, and we want him to get relaxed down, to calm down, we can immediately give it. Has very rapid onset of action, so we can give him through IV, and it will have an anesthetic effect on him. And then we have a phenobarbital. Its duration of day is longer than a day, or it's almost about a day. So it is also basically helpful against seizures and epilepsy disorders. Okay, and then secobarbital, amobarbital, and pentobarbital. Now, you guys should note here that these all three have the thiopental, which is being used nowadays, and phenobarbital, secobarbital, amobarbital, and pentobarbital are also used nowadays, but most important of them is thiopental. Okay, this one has pental in its end, and the others have barbital. Okay, you can use barbitol as an expression to remember. So and these seco, ammo, and pentobarbitals have sedative and hypnotic effect, but not anti-anxiety effect. So if you want to sedate a person for whatever reasons, you can use these drugs. Okay, what now their actions on or the effect on the CNS. As the dose increases, the effect on the CNS changes from sedative to hypnotic and eventually anesthetic. Now this is a graph showing that as if we increase the dose, we give initial dose is 0, so the effect is 0. The dose increases, it gives a sedative effect. Then more dose increases, it gives hypnotic effect. Now as the more dose increases, it gives anesthetic effect. And if we keep on increasing the dose, it even might lead to death. So we need to be very, very, very careful while giving that. So this is one more reasons why we do prefer them. We do not prefer them over benzos. Okay, and then we have effect on the respiratory system. They suppress the hypoxia and chemoreceptor response to CNS. And what is hypoxia? I'm sorry if it's not so clear. Hypoxia. Hypoxia is it's a lack of oxygen supply being assigned to the body cells. So it suppresses the hypoxia and the chemoreceptor response to CNS. Now this is done. Now we'll move on to the enzyme induction. This is cytochrome P450 system. So other drugs undergoing this pathway are rapidly eliminated. So what happens is in enzyme induction, so cytochrome P450 system, if it means induction means that it allows the other when some other drug is for example, if barbs are inducing this, okay, they are inducing this. So what happens is when I give another drug, for example XYZ, what will happen is it will allow its rapid elimination. It will reduce its half-life and it will be rapidly eliminated from the body. Okay, so its duration of action in the body will be reduced. So it can be sometimes it can